that's Jason. And Jason will talk about benchmarking ESP32 programs. That's probably something we also want to have in our tool set. And yeah, Jason, are you ready?
Yes.
Okay, then the stage is yours.
Thank you. Let's have a go then. Right, I believe this is the one. Okay, does that all come out well for you?
Yeah, nice.
Okay, so benchmarking on the ESP32FORTH, it all started off very innocently, really. I suppose the question you might start off with is, you know, why do it, right? Okay, I actually have to switch to my presentation itself, otherwise I can't. That's okay. Right, so why bother? It all started very innocently. I was just trying to understand, you know, when you are writing programs on ESP32FORTH, what is the throughput? Are we talking about, you know, 200,000 words per second? Is it 500,000 words per second? Is it 1 million words per second? And you know, I believe that there was not really a need for me to go very deeply, like actually understanding, you know, what is the interpreter actual throughput. You know, in that case, you would have to dig into the internals and see how it's written, and then see how often it's issuing another word. Because in fact, some of the words that we use may issue multiple dictionary words, perhaps. And I wasn't really necessarily interested in it. I just wanted to know, you know, the real words that I'm writing at Notepad or the terminal or whatever. You know, how many can I expect to be issued in a second? So that gives you a sense of the scale of the sorts of problems that you think you can tackle, right? You know, you don't want to start tackling a project only to find later on that, oh, you know, it may not be up to the task, right? You want to have some sort of sense that you know, you're in the ballpark already. You know, you can more or less do it. And then the other one, obviously, is to understand language quirks, right? I mean, especially as a beginner, you quite often want to get in very quickly into something, right? You want to understand, you know, should I use this language construct? Should I use that language construct? You know, which is better? And as we'll see, you know, quite a few of these turned up. And the benchmark isn't meant to be very exhaustive. I know it's a very simple test, but actually it came off the back of some other tests that I saw people doing, where they were doing empty loops, in fact. And to be honest, in my entire life, I'd never thought of doing empty loops before. But there you have it. You know, some benchmarks are even empty loops, and you know, people can get useful information out of that. So I worked on the idea of millions of operations per second. At some point, I thought, you know, since it's Forth and we deal with words, you know, when you talk about writing speed and all that, people talk about words per minute, right? I thought it might be interesting to have millions of words per minute. And, you know, some of us really like to know. And along my research, as it happens, you know, just searching for something else, you know, not even searching for benchmarks, just looking at Forth microcontroller, you will see that in fact questions like is Forth fast? And you know, we have a certain member of the group appears here, right? Howard Oakford, you know, and then how fast is the Forth language and so on. So it's clearly something that you know, people think about at some point or other for various reasons. And some of it is maybe, you know, you're writing a Forth interpreter and you want to know how fast it's going. So initially, I did not intend to check against the speed of MicroPython at all. In truth, I don't use MicroPython on microcontrollers. I already have a certain amount of brief over it at work, because we see a trend where people are putting where they could have used a 1 megahertz microcontroller before, they're putting 100 megahertz microcontroller in, just so that everybody can use MicroPython, right? And I don't know, maybe I'm a dinosaur, but it doesn't make sense to my type of engineering. But as it happens later on, I felt that having our benchmarks standing in an island without some sort of context, might not mean as much. So it's not a case of beating down MicroPython or anything like that. It's just a case of, where are we? Okay, fine. It's like we get a speed of like 1.5 million words per second. What does that mean? Compared to other tools you might want to use. So I actually had to come back and do some benchmarking of MicroPython later on, and and initially the speeds were quite different, and I was a bit surprised by that. But then I realized that, in fact, MicroPython starts up by default at 160 megahertz, and you actually have to speed it up to 240 megahertz if you want apples for apples. So there we have it. You could say that MicroPython does an equivalent of around actually 1 million operation or words per second, or almost 61 million words per minute. This is the code that I used on both. Like I said, it's not supposed to be highly optimized. The idea was that if it were just me or Christian or anyone else approaching it, this is the first thing we would probably type in, right? And how do they compare to each other? And all it does is it takes the initial start time in microseconds since boot up, and then it runs essentially I square pi and essentially discard the result a certain number of times, in this case 100,000 or 200,000 times. This figure of how many times I iterate is just a matter of making sure that we don't end up with a milliseconds that's too low, right? Because then you lose precision, although in reality we're after ballparks anyway, so it doesn't matter. And then after that we take the time when we complete, and we take the difference and so on, and then we do a little bit of maths to figure out how many words per second that was, right? And then as it happens later on, so you'll see that in fact I initially I was also trying to look at the speed of the new floating point stack that Brad Nelson had implemented, right? So that's what I was doing, but then I thought I should go back to it and then do the integer implementation. And initially I was using the code on the left, right, where I had a separate, where I was doing fixed point math, and I was doing the scaling separately later on. And as we discover in the results that well, Forth has a built-in multiplication with scaling word. That's the star divide word, right? That in fact you should use, and we'll see how that affects everything. Okay, so what I did was, the general procedure was confirm the operating frequency of the board and the various interpreters. I checked that the value being produced during all the iterations was as we expect. That was done using different scripts, right, to output text, which is not shown here, just to be sure that nothing strange was going on. Especially when when you get these results that are wildly different from what you expected, then you have to go and find out what's going on. We run the benchmark several times to make sure that you don't get values that keep going up and down or oscillating or whatever. And just now confirm came about. Basically, I just turned the LED on and off in an additional test, just because at some point I started to get results that were so wildly different that I needed to make sure that we weren't having a problem with milliseconds timing, tracking, and so on. So let's get right into it. Now, I don't have the whole battery of tests that were done on MicroPython. I only did the floating point one. So you see MicroPython essentially comes out at a scaling of 1 here, right? This is our control. And then what we find is that on the ESP32, we find that I found initially that it was about 1.6 times faster. And all right, fine, that makes sense, because MicroPython has object creation, garbage collection, all kinds of things. You'd sort of expect that, right? And then I also tested the ESP32C3, the RISC-V version. That one runs at 160 megahertz, I think. And then if you see that, then I tried the integer version, and I was a little bit surprised to find that in this case, ESP32 came out at only 1.3 times faster. But then I realized then, in fact, that what was going on was that, in a sense, I was using a separate divide function. Now, when I switched instead to using the built-in Forth star divide word, of course, then performance came back up again. Now, why is that? That tells us that, in fact, that interpreter overhead is big enough that if you run essentially if you run the built-in compound word, that in fact your main concern is interpreter overhead, right? And in fact, we can also get another conclusion out of this, is that even though the C3 does not have a floating point unit, interpreter overhead means that even if you're using emulated software floating point, you're not losing out hugely in comparison with the ESP32, which does have a hardware floating point unit. So that's good. And then running the test, at some point I realized that, in fact, I wasn't using the very latest version of ESP32FORTH. And when I switched to the latest version of ESP32FORTH and tried everything again, this is what I got. I was quite shocked, actually, because now we're seeing that when you're using the latest version, the .16 version of ESP32FORTH, the speed went up hugely. I'm not sure what Brad Nelson did, but it must have been extremely good. We're not talking about
I missed which version you were using before. I'm trying to guess what the difference is. What was the version you were on before?
Previous version was 7.0.6.
Scratching my head.
So it's effectively like double the performance now. So you get it is now 2.96 times faster than MicroPython. So this really threw me for it shocked me so much. I thought I was timing things wrong. I thought I was doing something wrong, and then I actually spent. So if you look at this, this first few slides, this took me, I don't know, almost nothing, right? And then I spent days on this trying to find out whether I'd done something wrong. But yeah.
Actually, can I see the benchmark? Actually, a second. I did happen to optimize variables in the midst of this. So if you were, let's see, were you using a variable? I'm now forgetting.
No, I wasn't.
No, you weren't.
I was just doing it.
Oh wow. Okay. Now you got me wondering the mystery of why the performance difference. That's awesome.
The only thing to say about this is that if you look at the but it's not even part of the benchmark. It's just my conversion later on to find out the millions of words per second. I was a bit of a dope at the beginning, and I didn't realize there was a built-in reciprocal floating point function, which I started to use later on. Yeah, so yes, as far as I can tell, these results are real. So everyone can rejoice. And then, and then as if that wasn't enough, then Peter said, you should use the for loop. So I went back and tried that again, and and get ready to be even more flabbergasted. So now with everything in a for loop, in floating point, you find that ESP32FORTH, the latest version, is now 13 times faster than MicroPython. And the integer version of the benchmark is 6.5 times faster than MicroPython. But then, you know, I didn't do an integer version on MicroPython, so I wouldn't really know. But as I said, you know, my initial intention wasn't really to compare against MicroPython. Yeah, Ted has his hand up.
Yes, thanks, Jason. I have just a few observations. First of all, this is a really excellent presentation. I don't mean to disparage anything you said, but you sort of like say you're measuring millions of words per second or minute, but you're really not, because there's lots of words in your loop.
Yes, actually.
Yeah, but really I see the value here where of iterating your own code. You've improved your own code and gone from 3 times a basic benchmark to 13 times a basic benchmark. This is really excellent. It's an excellent way to look at your time-sensitive code, etc., and really optimize it.
Well, I mean, it's worth saying that I didn't know what I was doing, and I still don't know what I'm doing, and I was very surprised. I was very surprised as to where it took me. I didn't know I was going to get here at all. And you know, I was looking at the starting forth book and so on, and it didn't mention the for, after, then, next at all.
Jason, we will share your code if you share with us
Yes.
both parts, Python and Forth, and we can put this on the Forth2020 GitHub, and we keep improving for next times, for next presentation. We show more about this. Probably the code will change or so.
Yes. I mean, otherwise you could be writing code, especially you know, there's no point to optimize the whole program, as everybody knows, you know. But there's always gonna be some sort of small critical path where it's worthwhile to do a bit of optimization. Okay, so
I'm less. By the way, I'm less surprised with the for loop versus the do loop. There is quite a bit of plumbing that has to happen around a do loop, and so you know, Dr. Ting is no doubt smiling if he's either here or from afar, as he's a big proponent of the for loop. But
yes. In fact, the only place I could find the documentation for the for loop was in Dr. Ting's documents. Okay, so this is the code that I used, and once again I was a bit of a dope, and I was copying different versions. But anyway, you see the intention with the different iteration numbers was simply just so that I didn't have excessively small milliseconds coming out. Okay, and then this is not something I did initially, but you know, when Peter says, "Can you make a presentation?" all of a sudden you crap your pants and say, "Oh gosh, you know, I've got to get a bit serious here." And yeah, the reason for the confused basketball player in the corner is because well, you know, we see the ESP32FORTH firmware sizes here. Where's the MicroPython size? Well, actually, it's there. It's just that it's so small you can't see it. It's actually I think they're like 1.5 megs. For the it's 1.5. I don't know. Let's see. What is it? Yeah, it doesn't appear. It doesn't appear. It's in there. No. Sorry. I've typed this up wrongly, I think. So MicroPython is actually 1.5 megs, and ESP32FORTH comes out at about 877 kilobytes in size. But remember, that's also because it includes a lot of Forth source that gets compiled at boot up. So you know, maybe slightly misleading there.
The difference is in ESP32FORTH, you have a lot of tools. You have an editor, you have the web interface, all these things.
Yeah, that's right. Yeah, I think I've got some of this wrong somewhere.
This can be a next experiment for you to go after.
Yeah,
the part of the tools, how much memory each is using.
Yeah, I think I've screwed this up actually somehow. This doesn't sound right at all. Yeah, so conclusions. The version of the presentation I sent to Peter actually didn't have any conclusions at all, because I thought it sort of spoke for itself, but then we can come up with some conclusions actually. One of the suggestions that Peter had was use constants, and in fact, the pi built-in word is very slightly faster than using literal constants. I have no idea why. And then we now know that for-next is much faster. Yes, we understand that do loop does a lot of stack manipulation, and interpreter overhead. Interpreter overhead features very heavily in the benchmarks that we can see. So wherever you can, definitely use compound words. And that's about it. I think in future, what I would like to look at, I would say that I considered, for-next as an additional word, and then I considered do loop as one word, right? Which in reality it's several stack manipulations. So it's not quite right. But to me, when I look at it, I think, okay, about 3, you can sort of expect about 3 million words per second to happen on the latest version of ESP32FORTH. And then you should have some sort of an idea, if you were trying to think, okay, if I wanted to measure a signal of a certain speed, entirely within Forth without dropping into Arduino and writing special words in C and so on, would I get away with it? Then at least you would have some sort of an idea of what it can do. And also, everybody update to the latest version.
Yeah. So yeah, thank you very much. There's a question from Matteo in the chat, and he says, "Why do you use different amount of iterations in these various loops?"
Oh yes, well, it's simply because I started off with about 100,000 iterations, and then I also tried 200,000 iterations to see whether there was a big difference. The main intention was to stay within about between like 400 to 600 milliseconds execution time, and then later on when I got to the for loop, of course, for loops. Threw everything out the window, right? And you had to use a longer iteration. That was the only reason, really.
I see.
That's fine.
Yeah, thank you very much. Are there other questions? Yeah, Jan is raising his hand.
Yes, I have a question about changing the speed from 160 megahertz to 240 megahertz. How did you do that?
I think there is a system module that you need to include. Yes, okay, no, I believe it's in SYS. It appears in the post I originally did in the Forth2020 group. Do you mean how do we do that in Forth, or how do we do that in MicroPython?
In Forth, please.
All right, I see. I didn't try that. There are words for getting the frequency that already exist, but I didn't try to change the speed in Forth. I only did it for MicroPython because it was coming in slow at boot up. Maybe okay, Brad can answer that.
Yes, I was going to ask him.
Sorry, was looking at the chat. Sorry, what was the question? I didn't quite get that.
How do you change the operating frequency in Forth?
I don't know that I have anything exposed that does. That's a good thing we should add, actually. Do you know why MicroPython just doesn't go with the fastest clock speed? I guess it's a power thing, right? Flexibility for low power.
Yeah, I guess so. I was surprised.
Yeah, it's a little counterintuitive that they would default it to the lower clock speed.
Yeah, and if I didn't happen to check, then you know, and the reason why I checked was simply because after I updated to the latest version of ESP32FORTH, I got those wild numbers. I thought, whoa, what's going on here? You know?
Right.
So if anyone one day finds out how to do it in Forth, I would ask you to announce it on the Facebook group, because I need the speed a lot.
At least the default one you can set in the Arduino IDE when you pass it. So like that will set the initial value. I don't know. I need to look into what's involved in dynamic loading. But if you just want to set it globally, you can set it in the Arduino IDE. In fact, ESP32FORTH.
Okay.
Mm-hmm.